Hello, my name is Jason Mashinchi, and I'm here today with Javier Camara from the University of York to present a new software architecture visualization tool called Voyager. In the next 10 minutes, I'm going to briefly cover what we've built, starting with the problem we're trying to solve, and how existing tools have approached it, and what our approach and solution is. I'll give a live demo of Voyager in operation, and I'll discuss how we evaluated the tool and what the next steps are. Software systems must satisfy a variety of functional and non-functional requirements to fulfill its intended purpose. Some of the feasible architectural configurations for the system may satisfy non-functional requirements better than others, even if they are functionally equivalent. These non-functional requirements define attributes like power consumption, performance, and cost that can be used to compare amongst alternative architectural designs. There are often trade-offs between these attributes. For example, to get higher performance, components may incur a higher cost. Complex architectural designs often have many dimensions of concern. This results in poorly understood design spaces, in which understanding the trade-offs can be challenging for a software architect. Within an architectural design process, once possible architectural designs have been identified, the architect needs to evaluate the quality of each of these and decide whether an architecture is good enough to keep considering. This set of architectural designs and the quantified values of their attributes feed into the next of the evaluation phases. This flow diagram on the right shows an outline of this process. The section we're focusing on for this tool is the evaluation and stopping criteria part in the middle. The aim of the evaluation process is to find the best architectural options. To do this, it is vital to get an understanding of the quality attributes available and the trade-offs amongst these. This is typically done by analysing these data sets in general-purpose tools like spreadsheets, or by making use of existing multi-objective optimization tools for this purpose, and using separate tools to evaluate the architectural structure for each configuration. Existing tools surveyed include Clayfor-Mu Visualizer and TradeMaker. These tools are good for comparing amongst many architectural configurations, as they include visualizations like 2D bubble plots and matrices representing the distribution of configurations in relation to their quality attributes. However, they don't include architectural structure information, making it difficult to understand how these attributes relate to the structure itself and understanding the structural trade-offs. Other tools are focused on architectural structure visualization and are effective for analysing a single architecture at a time, but less so for comparing amongst multiple options simultaneously. So what's our approach? We aim to provide a user-friendly tool that facilitates the exploration and analysis of these datasets, combining the benefits of multi-objective trade-off analysis with architectural structural visualizations in a novel way. In contrast to other tools, Voyager has been designed to enable a better understanding of the architectural design spaces through the explicit link between structure and quality attributes. We've focused on providing context-sensitive visualizations, which make it easy to narrow down the dataset and allow users to fully comprehend the architectural trade-offs in the design space and understand the common features and structures of matching architectures. Let's move on to a demo where we can see exactly how the tool works. Okay, so as you can see, this is the main Voyager user interface, and you're looking at the Solution Explorer. So it consists of three parts. You've got the attributes section at the left, where you can see the quality attributes in your dataset. You've got the configurations panel in the middle, where you can see all the possible configurations there are. And you've got this area here on the right, which will either contain visualizations or details about each configuration. So to import data into Voyager, you can press the import button in the top right-hand corner, where you can either select a JSON file or a CSV file. In this case, you've already loaded one in. So to get started, let's run through a few problems that we used for our user study. So the first problem is to try and identify the configuration with the lowest cost. In Voyager, you simply click on Cost in the Attributes column on the left. What this will do is order the configurations list based on the value of this attribute and present you with contextually sensitive visualizations which are relevant to the context. In this case, we've got line charts and bar charts as we've only selected one dimension. To get details about any configuration in Voyager, you can simply click on it and you'll get this panel on the right hand side showing the attributes, a radar chart with relative values compared to other configurations, and a structure chart showing you the architectural structure of this configuration. With any visualization in Voyager, you can click in the top right hand corner to export or save your visualization. Okay, moving on to a more complicated scenario now. Let's say we want to find out which configurations have the highest possible battery life and the highest possible range. To do that, simply click on the attributes in the left-hand column and then select your optimization aim. In this case, for both attributes, higher is better. As you can see, the visualizations pane is adapted to show you more relevant visualizations. So in this case, we've got a 2D scatter chart and a radar chart showing you the Pareto optimal configurations at the top. We can use the Structures tab to compare multiple configurations side by side and see the structural differences in their architectures. In addition, we've got the Comparison tab, which allows us to filter by Pareto optimal configurations and by the differences, so you can quickly and easily see the differences between your optimal configurations. So now let's say we have a constraint that the reliability needs to be at least 8. To reflect that in Voyager, click on Reliability in the Attributes list and change the minimum value of the range slider up to 8. As you can see, this reflects in the visualizations instantly. In this case, the 2D scatter plot is showing multiple configurations at each point. So to get more detail on this, we can click on the 3D scatter view and see actually they look to be the same values in reliability and range, but vary in terms of battery life. We can switch projections to make this easier to see. If we go to the surface plot, we can actually see the optimal configurations at each point. Likewise, we've got the map, which shows similar information in the 2D format. So to understand why these configurations happen to have similar values, if we go to Comparison and filter by structural differences, we can quite obviously see half of the configurations, the more optimal ones, have the bigger battery, and the other configurations with the same values for range and reliability had the smaller battery size. In addition to this, Voyager also allows you to quickly save visualizations in shortlisted architectures for later, presenting them in a report format you can access in the top toolbar. Voyager can show relevant visualizations for up to 5 dimensions of selected attributes at a time. For additional architectural structure visualizations, there is also an Extensions API, which allows external tools to provide custom tabs and data sources via HTTP. Okay, let's go back to the slides. We conducted a user study where we asked participants to solve a set of questions probing the architectural design space for a set of configurations. Our user study showed that Voyager is effective for use with multi-dimensional architecture trade-off problems. We gave participants 2 tools, a spreadsheet to gather a baseline, and either Voyager or Clafamove Visualizer, a comparable existing tool. Participants were asked to rate the tools they used based on a series of usability questions according to a 5-point Likert scale. This was combined with the correctness scores of the answers they provided to give us an overall result. Our results show it had a significantly better user experience compared with the other tool, and it allowed participants to achieve a higher accuracy of answers in a shorter time span. So in conclusion, we have developed a novel solution that combines architectural solution space exploration with architectural structure visualization, which helps architects to analyze and narrow down their design options. Our evaluation has demonstrated Voyager's ease of use and effectiveness with users, allowing our participants to get better answers to these sorts of questions faster. There is scope for future work, of course, including implementing new visualization ideas, as well as enhancing our support for external tool integrations. In addition, as pointed out by one of our participants, there is potential for the use of Voyager in other fields that also have similar structural-based multidimensional datasets with similar trade-off problems. Our tool is easily accessible and open source on GitHub, so we encourage you to check it out, and we welcome any open source contributions. We would also love to hear how it gets used by other teams. So finally, thank you for listening, and we look forward to answering all of your questions.